What is a biological safety cabinet, or BSC? It is an engineering control that removes particulates, for example, aerosolized infectious agents, at the point of generation. This ventilated enclosure utilizes high-efficiency particulate air, known as HEPA, filters, and directional airflow powered by a motor blower apparatus to remove particulates and aerosols in order to provide protection. The three types of protection provided by a BSC are product protection, whereby research materials are kept sterile by laminar flow, which is a single speed and unidirectional curtain of HEPA-filtered air onto the work surface that prevents the cross-contamination of research materials by reducing turbulent wind patterns within the BSC. Personnel and environmental protection, which means you are protected from biohazardous materials because of the inward directional air curtain at the front of the cabinet, which prevents the escape of potentially contaminated air out of the BSC prior to HEPA filtration. Of note, the air curtain draws dirty air in from the room and is immediately directed into the BSC plenum in order to be HEPA filtered prior to being blown upon the work surface or exhausted out of the BSC. This air curtain affords product, personnel, and environmental protection as it prevents you, the worker, and the lab environment from being exposed to potentially contaminated air within the BSC. It also protects your research materials from being contaminated with the potentially contaminated air that is drawn into the BSC from the room. One of the key components of a biological safety cabinet are the HEPA filters. What is a HEPA filter? A HEPA filter is a high-efficiency particulate air filter that traps particles. A HEPA filter does not trap gases or vapors released by hazardous compounds. By definition, a HEPA filter has a minimum efficiency of 99.97% for capturing particles at the most penetrating particle size of 0.3 micrometers. This size is most penetrating due to the physics of particle movement through the air. The filter is comprised of thin glass fibers made into a filter medium that resembles folded paper. These fibers trap particles by three different mechanisms: impaction, which is most efficient at capturing the largest particles, interception, which captures medium-sized particles, and a diffusion, which captures the smallest particles. The efficiency of capture for each mechanism is shown here. As you can see, as particle size decreases, see the x-axis from right to left, impaction becomes less efficient, as does interception, but interception remains highly efficient down to about 0.4 micrometers. Diffusion does not become a highly efficient method of capture until around 0.2 micrometers. This means that particles in the 0.3 micrometer range are the most difficult for the filter to capture. However, the combined efficiencies of the three mechanisms, see the line on the graph for overall efficiency, still remains at 99.97% at that 0.3 micrometer size. This means that the HEPA filter captures 99.97%, or 9,997 out of 10,000 particles of the 0.3 micrometer size. It is more efficient at capturing larger or smaller sized particles. This is a performance standard, which means that each HEPA filter is tested to verify that it meets this criteria. Additionally, as a HEPA filter loads with particles, it becomes more efficient at trapping particles, since there is more surface area on which particles can become stuck. A final word about HEPA filters as they relate to BSCs. There are two HEPA filters in each BSC: the supply HEPA filter, which provides clean air down over your work surface, and the exhaust HEPA filter, which cleans the air before it is released to the room or environment. We will now talk more about BSCs themselves. There are three classes of BSCs. However, the most commonly used is the Class 2, which is what will be discussed here. If you use a Class 1 or Class 3 BSC, you should receive special training from your PI. Types A1 and A2 are almost identical, and the key facts about these types are that they recirculate the majority of the air within the cabinet, 70%, and exhaust a small portion, 30%, out of the cabinet back into the room. The Class 2 Type A1 and A2 BSCs recirculate 70% of air. Therefore, you should not work with toxic or flammable gases or vapors, as these could increase in concentration to combustible or dangerous levels, as they cannot be trapped within the HEPA filter. Also, air exhausted back into the room that contains these gases and vapors could be harmful to the user. Alternatively, the exhausted air can be captured by a thimble or canopy connection and drawn out of the room through the building exhaust system, which can mitigate the risk of very small amounts of gases and vapors released into the room. This will be discussed further later on. Type A2 cabinets are the most common type of BSCs used at UC Davis. The Type B1 and B2 cabinets exhaust either most of or all of the air from the BSC, which means buildup of gases or vapors is not likely to occur. The HEPA-filtered air is pulled out of the BSC through a duct by the building exhaust. The duct is hard or directly connected to the BSC. These types are only used if your research program combines biohazardous materials with moderate amounts of volatile chemicals or toxic compounds. The Class 2 Type A2 BSC is the most commonly used BSC. This diagram shows the airflow pattern and the key features of this type of BSC, including the exhaust HEPA at the top of the unit, where exhaust air is HEPA filtered before exiting the BSC, the motor blower, which moves the air through the BSC, the supply HEPA, which filters the air before it is blown down onto the work surface, which is where your research materials are handled, the front and back grills, where contaminated air is pulled away from the work surface, the sash, which helps contain the air inside the work surface, and the opening, where you access the work surface. At this opening, room air is drawn into the BSC at 100 feet per minute. 100 feet per minute is roughly equivalent to 1 mile per hour. At this pace, a person will take about 2 seconds to walk a 3-foot distance, which is slightly longer than the average stride length. This inflow of air at the opening creates a delicate curtain of air that serves as a barrier between you and the biohazardous materials inside the cabinet. This delicate curtain of air can easily be disrupted. If this happens, personnel, product, and environmental protection is lost. Once air enters at the opening, it is immediately drawn down under the work surface. The air then travels up the back plenum, where it is either HEPA filtered and exhausted out of the cabinet, 30% of air is exhausted, or recycled into the work surface through the supply HEPA filter. 70% of air is recirculated in this way. Class 2 Type A2 BSCs can be tied into the building exhaust system through the use of a canopy or thimble connection. A canopy connection schematic is pictured on the left. Note the gap around the bottom that allows airflow in from the room. This canopy exhaust also draws the air coming out of the BSC and carries it out of the building. The canopy connection enables users to manipulate small amounts of volatile chemicals or toxic substances in conjunction with biological materials. If the building exhaust system momentarily fails, the A2 BSC will still continue working to provide protection from the biological materials, but gases and vapors will be exhausted into the room rather than being removed. In contrast, the B1 and B2 type BSCs are directly connected to the building exhaust. There's no gap between the BSC and the exhaust duct, as you can see in the picture on the right. The direct connection, combined with the low percentage of recirculated air inside the B-type BSCs, allows for the use of volatile chemicals. This is a summary of the 3 types of Class 2 BSCs that we have covered. Remember that Type A2 cabinets recirculate 70% of the air within the cabinet and exhaust 30% either back to the room or out through the canopy connection. This recirculation within the cabinet means flammable vapors can build up inside the BSC, so this type of cabinet is discouraged for use with flammables. Minute quantities of volatile chemicals or toxic substances may be used if the A2 is connected to a canopy. The B1 BSC recirculates only 30% of the air within the cabinet, and the rest is exhausted through a hard ducted connection to the building exhaust system. This means that small amounts of volatile chemicals or toxic substances may be used, but due to the design of the cabinet, it is important to confine work with these materials to the rear of the workspace. Finally, the Type 2 B2 BSC does not recirculate any air within the cabinet and 100% is exhausted, which means that volatile and flammable chemicals and toxic materials are directly exhausted. It is important to remember, though, that the B2 is costly to install, operate, and relocate. Often the HVAC of the room will need to be reconfigured to account for the B2 BSC. B2 BSCs are also unnecessary for the majority of biological work. We have covered what a BSC is and how it provides product, personnel, and environmental protection against biohazardous materials. There are several other ventilated enclosures that you may encounter that are not a biological safety cabinet. The first is a chemical fume hood, which does not protect your research materials since unfiltered or dirty air flows directly across the work surface. It also does not protect the environment from biohazard material release because there is no HEPA filter on the exhaust. The second is a laminar flow hood or a so-called clean bench. The air blows out of the enclosure and into the surrounding environment without being filtered. Thus, you're exposing yourself and the lab to whatever is being manipulated on the clean bench. Therefore, it is imperative that you never work with anything hazardous or biohazardous on a clean bench. Since correct airflow through the BSC is essential for product and personnel protection, it is very important while working in a BSC that the air curtain is disrupted as little as possible. The first thing we can do to help avoid disruption of airflow is to plan your experiments carefully. Before you begin work, be sure to turn the BSC on and observe the magnethelate gauge, if present, to ensure that the unit is working as expected. Next, decontaminate all of the interior surfaces of the BSC with an appropriate disinfectant. Then place the items you need for your experiment into the BSC, surface decontaminating each item as you put it inside. It is important to minimize the amount of materials and supplies inside the cabinet so as not to block or disrupt airflow. Introduce your biohazardous materials last. Whenever possible, you should set up your workspace in an organized manner. This will help keep your research materials from cross-contamination and reduce your movement in and out of the BSC, thereby maintaining the delicate air curtain. This diagram represents an ideal layout for working in an organized and efficient manner in a BSC. It is often referred to as working clean to dirty. Clean cultures, left, can be inoculated, center, and contaminated pipettes can be discarded in the shallow pan, and other contaminated materials can be placed in a biohazard waste receptacle on the right. This arrangement is reversed for left-handed persons. The following are some general principles for actually performing work in the BSC. Use an appropriate lab coat, for example, a barrier lab coat when working with bloodborne pathogens, that have a tight-fitting cuff, ribbed elastic cuffs, for example, or tuck the lab coat cuff underneath the glove. This will reduce chances of knocking over materials and supplies inside the BSC. Since you may sit at the BSC for an extended period of time, you will want to sit comfortably in front of the cabinet and in such a way as to minimize airflow disruption with your forearms. Assume a comfortable position. Adjust seat height so that armpits are level with the bottom of the sash. This helps ensure that you will have a clear line of sight through the BSC window and your arms will be ergonomically positioned to work within the cabinet. Another key component to maintaining containment is the movement of your hands in and out of the BSC and also around within the BSC. Move slowly, and if you must remove your hands, do so in a back and forth manner perpendicular to the sash rather than by swooping in and out. Work should be done in the middle of the work surface, about 4 inches back from the front, to ensure that droplets or aerosols do not exit the BSC, which could happen if work is performed too close to the opening. Additionally, you want to minimize the generation of any excess aerosols or splashes, splatters, or droplets. To do this, work carefully. For example, open the lids of tubes slowly and pipette gently. There are several things that you should avoid doing while working in the BSc in order to maintain protection of your research materials and of yourself. Do not work with the sash above the appropriate height, often indicated by arrows or an audible alarm. Do not overload the cabinet with unnecessary items, as this can disrupt airflow and make it more likely to cause a spill or cross-contaminate your materials. Do not block the front or back grill with papers, pipette boxes, waste bags, etc. Again, this disrupts the airflow and compromises the BSc's safety features. Do not introduce any non-disposable porous materials, for example styrofoam, into the BSc, as these items cannot be decontaminated and are therefore inappropriate to work with in the presence of biohazardous materials. When you have finished working, you must clean up and remove everything from the BSc, as ideally nothing is stored inside of the BSc in order to maintain a clean environment. Everything that is removed from the BSc must be surface decontaminated with an approved disinfectant. Anything that went into the BSc needs to be decontaminated on its way out, even if it didn't have direct contact with biohazardous materials. This includes tubes, racks, plates, flasks, and centrifuge rotors, as well as waste containers, animal cages, pipettes, and so on. If your disinfectant is corrosive, be aware that you should follow the disinfectant step with an ethanol or water rinse. Also, avoid spraying bleach solutions inside the BSc, as the aerosolized bleach can get sucked into the cabinet and corrode the inside. Instead, use a squirt bottle to apply the disinfectant onto the surface or onto an absorbent material such as a paper towel or a Swiffer. After everything is removed from the BSc, decontaminate the inside surfaces of the BSc itself. Work surface, back of the cabinet, left and right sides of the cabinet, and the inside face of the sash. Finally, if a small spill of biohazardous materials occurs inside the BSc while you're working, be sure to stop and clean it up before proceeding with your work. For spill response guidance, please refer to the EH&S Safety Net 127 Biological and Biohazardous Spill Response. The surfaces underneath the work area should be cleaned regularly, especially after a spill. Refer to your user manual for your BSc on how to clean the bottom underneath the work surface.
This video demonstrates how biological safety cabinets work to protect you, providing protection to laboratory workers, product, and the environment while reducing the risk of exposure. Thoroughly understanding how a biological safety cabinet works while following established lab safety protocols will help prevent contamination of your work and protect you at the same time. When used correctly, a properly installed and certified biological safety cabinet provides personnel, environmental, and product protection for work with biological materials, including infectious agents and recombinant DNA. This video depicts a freestanding Class II Type A2 biological safety cabinet, or BSc. It includes HEPA filters for exhaust and supply air, the work surface, the opening to the work surface, the airfoil, front and rear air intake grills, the plenum. The BSc's air filtration system works to keep potentially contaminated air from seeping back onto the worker. Air flows through the window opening into the front grill, through the plenum, then through the HEPA filters. 30% of the filtered air is exhausted. The remaining 70%, which is now HEPA filtered, is recycled back into the workspace. To ensure maximum protection in using a BSc, here are some essential reminders. 1. If the cabinet has been turned off, you must turn it on and wait at least 15 minutes before beginning your work. 2. Set up the interior workspace to work from clean to dirty, and work consistently from one direction toward the other to prevent cross-contamination. 3. Place your chair at a comfortable height and in the middle of your workspace to ensure you can reach everything you need inside the cabinet without discomfort. Please keep in mind that you must work at least 10 centimeters inside the BSC. To guarantee uninterrupted airflow, cabinets should never be overcrowded. Overcrowding the BSC can block air grills. Airflow can also be disrupted by sudden or sweeping movements. Slow, direct movements work best. Too much foot traffic can cause problems as well, and should be kept at a minimum. If pedestrians are unavoidable, keep people at least 1 meter from your BSC. And remember to check nearby doors or supply vents to determine if they disrupt the cabinet's airflow. When you have completed your work, any reusable items should be wiped down with disinfectant before removing them from the BSC. Next, the interior surfaces of the BSC should be decontaminated using the appropriate disinfectant for a contact time recommended for the agent used. To be sure, a second decontamination is advisable. In summary, there are a small number of best practices to follow in using a biological safety cabinet. Let's go over them one last time. Work at least 10 centimeters inside of the BSC. Do not block front and rear grills. Too many objects in the BSC can disrupt the airflow. Set up workspace in a direction from clean to dirty. Use slow, direct movements. Minimize foot traffic within 1 meter of the BSC. Placement of the BSC away from doors and room air supply vents helps maintain airflow.
We will now discuss several campus policies regarding biological safety cabinet use at UC Davis. The first deals with ultraviolet light use as a disinfection method in the BSC. Most BSCs are equipped with ultraviolet or UV lights. The UV light damages the nucleic acids of microorganisms, which makes them non-viable. However, the usefulness of UV light can be easily compromised if any items are left in the BSC that could cast a shadow on the surface, thereby preventing the radiation from reaching and destroying any biohazards in the shadowed area. Similarly, if the surface is dirty, the radiation may not penetrate to destroy the nucleic acids of any biohazards. The light bulb itself can lose intensity due to age or dust settling on the bulb, both of which can reduce the efficacy. If your lab uses the UV light as a mechanism for disinfection, you must keep a documented record of routine cleaning and maintenance of the bulb. A secondary method, such as chemical surface decontamination, should also be used. According to campus policy, biological safety cabinets must also be certified at regular intervals by an accredited technician in order to be used for biohazardous materials. There are specific instances when the BSC must be certified. These include upon initial receiving and installation of a new BSC, after any relocation of a BSC, after maintenance on the BSC, at least annually, and if the HEPA filter integrity is thought to be compromised, for example, after a major spill. Contact the Biosafety office when you think this is the case. The technician will perform the following tests: checking the velocity of the airflow into the BSC to make sure it is fast enough to maintain personnel protection, the velocity of air down onto the work surface, checking the HEPA filters to ensure that they still capture 99.97% of 0.3 micrometer particles, and airflow patterns within the BSC. It is important to remember that the BSC must be decontaminated in order for the technician to complete their job safely. The method of decontamination depends on the risk of the biohazardous materials that have been used in the BSC. Other campus policies are: no open flames may be used in a BSC. There are several reasons for this. An open flame disrupts the air curtain, which can compromise personnel and product protection. An open flame can damage the HEPA filter. An open flame can lead to a fire in the BSC. Another approach is to use disposable single-use items, such as plastic loops and spreaders, rather than their metal or glass counterparts. Furthermore, only one person may work in a BSC at a given time, regardless of the size of the BSC. All BSCs are manufactured and certified for use by a single operator sitting centrally. 2 or more operators will disrupt the air curtain, compromising personnel and product protection, interfere with one another's movements, increasing the risk for spill or other accidents, and possibly contaminating each other or each other's work. The final policy describes what is expected when planning, purchasing, installing, or relocating a biological safety cabinet. First and foremost, don't hesitate to contact Facilities Management and the Biosafety Office for guidance. When planning for installation of a new BSC or relocating an old one, consider the following. Is the doorway to the lab large enough to fit the BSC through? Is the ceiling high enough for the BSC? Remember, there must be at least 12 inches of clearance above the BSC for testing purposes. What kind of ventilation is currently in the room? What about the power supply? Is it sufficient to run the BSC? It is also important to select the appropriate BSC for the planned work and consider that a canopy-connected A2 BSC and hard-ducted B1 and B2 cabinets can be expensive to install since ductwork is required. If you are not using chemicals, then ducted BSCs do not offer any advantage compared to a regular A2, and indeed a recirculating A2 cabinet may be your best option. When purchasing a BSC, there are several brands that are known to be of quality construction and are pre-approved. These are Baker, New Air, Thermo Fisher, and Lab Conco. EH&S will approve purchases of other brands if the quality and performance standards match those of the preferred brands. Importantly, all new cabinets must be able to meet certification by NSF 49 standard. Placement of a BSC within a room is important to maintaining the delicate air curtain at the opening of the work surface. As we learned previously, any disruption of this curtain can result in loss of personnel and product protection. Therefore, it is campus policy and also best practice to install the BSC out of high foot traffic areas, away from air supply and exhaust registers, away from windows and doors, all of which can create air currents that may disrupt the air curtain at the opening of the BSC. Again, if you have questions about placement of a new or relocated BSC, contact Facilities Management and the Biosafety Office for guidance. If you need to relocate a BSC, be sure to use campus special services for moving. The BSC will need to be gas decontaminated by a contractor before being moved if it was used with Risk Group 2 or Risk Group 3 biohazards. A thorough wipe down with an appropriate disinfectant is usually adequate for BSCs used for other purposes. Finally, no BSCs, new or relocated, will be connected to gas lines in order to discourage open flame use. In summary, biological safety cabinets offer product, personnel, and environmental protection. In order to consistently offer these protections, the BSC must be used properly, which hinges on maintaining appropriate airflow. We learned that the air curtain at the opening of the BSC protects the worker, but can easily be disrupted. The downflow of air provides product protection. In addition, to preserve this protection, work must be conducted carefully within the BSC, with special attention paid to movement of hands within the cabinet as well as into and out of it. You must also employ thorough and appropriate disinfection practices. Finally, a number of campus policies govern BSC use at UC Davis. To review those policies, please visit the link at the bottom of this page.